Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about simulation. Paul the Octopus was an octopus that lived in Germany, and he became famous during the 2010 World Cup soccer tournament when he correctly predicted the winner of all 8 matches he was asked to predict. Before each match, 2 containers of food were lowered into Paul's tank in a German aquarium. Each was labeled with a flag from one of the opposing teams. He made his prediction of the winner of the upcoming soccer match by choosing which container to eat from first. We want to know, is Paul psychic or is something else going on here? So we're going to run what's called a simulation. And a simulation is the imitation of chance behavior based on a model that accurately reflects the situation. So in essence, we're going to mimic the situation, assuming it was purely chance that Paul picked these, and see what the probability of Paul's outcome was. The first thing we want to do is we want to set up the trial using random numbers. So since the probability of Paul randomly selecting the winning team is 50%, we need to make sure that we choose numbers that represent that probability. Now we have quite a few options here. We could use the numbers 1 through 10 and have odds be that he correctly picked the winner and the evens be that he incorrectly picked the winner. We could use 1 through 10 and have 1 through 5 be that he correctly picked the winner and 6 through 10 being that he was incorrect. Or we could keep it simple and say we're going to use the numbers 1 and 2, with 1 being that Paul was correct and 2 being that he was incorrect. For this example, we're going to stick with the easiest and simplest option of using 1 and 2. So what we're going to do is we're going to select 8 numbers to represent the 8 games that Paul chose. Here, repeats are allowed since each number represents the outcome of a different game. Remember, on your TID4 calculator, you can use the rand_end function with a lower of 1, an upper of 2, and we want to select 8 at a time. We're going to record the number of correct picks or the number of ones from each of our trials. Let's go to the calculator and see what that looks like. We could go over here to Math, over to Prob, and then down to number 5, which is rand_end. We want our lower value to be 1, our upper value to be 2, and 8 to be the number of values we're given. We're going to paste this into the calculator and hit Enter. Now for this trial, we're going to count the number of ones. 1, 2, 3, 4. So in this trial, Paul correctly picked 4 of the games correctly. We can run a second trial again by hitting second Enter, and then Enter again. In this trial, there were 3 ones, so he picked 3 games correctly. Now, we want to repeat this for many trials. Here's a table of 12 trials that I ran earlier. So for each trial, we would record the number of correct games that Paul picked or correct guesses that Paul picked. And we want to do this a large number of times. So here is a dot plot from over 100 trials that I took, and you can see that none of them resulted in 8 correct guesses. So according to our simulation, the probability that Paul guessed all 8 winning teams randomly is 0 out of 100, or 0. Now we want to go ahead and answer the question we were originally asked. Is Paul psychic? Or is there evidence that Paul is psychic? Well, we would have to say here that according to our simulation, and it's important that we say that since this is based on data from our simulation, that the probability of randomly choosing all 8 winning teams was 0. Since this probability is so small, there is convincing evidence to suggest that Paul did not just randomly select these winners. Now remember, at the beginning of the year, we talked about how we usually compare the probability of something occurring to 5%. If something happens randomly less than 5% of the time, it's considered convincing evidence that something else is going on. If it occurs randomly more than 5% of the time, we could say that it probably occurred just due to random chance. So for simulations, there's 3 steps here just to review. Set up a trial, perform many trials, and then analyze the results and answer the question. We're going to do another example, but I'll let you enjoy this Venn diagram joke for a minute. Cereal. Let's say there's a cereal company and it's doing a promotion by putting Naruto toys in their cereal boxes. There's one of 4 toys that will be placed randomly in each cereal box. Assuming that the shipment of boxes is random, how many boxes would you have to buy to guarantee that you got all 4 toys? Now here, they're not asking us to run a simulation, but just to describe how we would run a simulation. These types of questions are pretty common on the AP exam. First step, set up a trial. Since there are 4 Naruto toys, we would use the numbers 1 through 4 to represent each toy. We would then use a random number generator to find numbers from 1 to 4 one at a time, and we would stop when we have found all 4 numbers at least once. Here, again, repeats are allowed since each number indicates a different cereal box. We will record how long it takes us to get all 4 numbers at least once. We would repeat this for many trials, and here we're not actually doing it, so we should make the comment, hey, we will repeat this for a large number of times. Analyze results. We want to talk about what we would do after we ran our simulation. Well, we would take the results of our mini trials and find the mean number of boxes it took to get all 4 Naruto toys. This would be the expected number of boxes of cereal it will take to get all 4 Naruto toys. Thank you for joining me. I will leave you with this quote by John Ruskin. Have a great day.